Assalamualaikum and hi everyone, I'm Atika. Ohayo, I'm Hidayah. Today, we would like to talk about the geometric distribution in our real life. As we all know, in some board game, we cannot move forward until we roll a specific number, which of course could take several times. Manufacturers of products such as switches, relays, and hard drive need to know how many times their product can perform before failing.
And in some sports competition like Kurokuro basket or basketball game, the winner is the player who scores the most points before missing a shot. The waiting time can be defined as the number of trials before a specific outcome occurs.
So now, let's take a look into some situations that related to these distributions.
So, Atika, let's answer that question. What is the probability for getting out of jail in X rows of the dice? Okay, firstly, we need to know that the random variable is the number of unsuccessful rolls before we get out of jail. We can get out of jail if we get doubles from the dice, and p doubles equals to 6 over 36, and it can be simplified to 1 over 6. So for each independent row, p equals to 1 over 6, and q will be 1 minus p, and we can get 5 over 6.
We can apply the product rule to find the probability of successive independent events. Thus, each unsuccessful roll preceding the successful one adds a factor of 5 over 6 to the probability.
This distribution theoretically continues forever, since one possible outcome is that the player never rolls double. However, the probability for a waiting time decreases markedly as a waiting time increases.
Although this distribution is an infinite geometric series, its terms still sum to 1 since they represent the probabilities of all possible outcomes. So now, let's try to estimate the expected number of rolls before we can get out of the jail. Firstly, we need to calculate the first 6 term, where x starts from 0. If this term approaches 0 rapidly, the sum of these terms will give a rough first approximation to the expectation.
Clearly, 6 terms are not approaching 0 rapidly. All we can conclude is that the expected number of rolls before getting out of jail is definitely more than 1.3.
嘘だろ。ありえない。俺のあのシュート。今のもらい。
So, for the next example is a free throw in basketball games. Let's say Hatake has a success rate of 68% for scoring on free throw in basketball. What is the expected number of trials before he fails on a free throw? Here, the random variable is the number of trials before Hatake fails to score on a free throw. For calculating the waiting time, a success is Hatake fails to score. So P equals to 0.68 and Q will be 1 minus P, and you'll get 0.32. Using the expectation formula for geometry distribution, we can find Ex equals to P divided by Q, and we can get 2.1. The expectation is that Hatake will score on 2.1 before missing free throws.
가쇼다!
관리?
The last situation is on traffic management. Suppose that an intersection that Heiji need to pass on her way to work has a traffic light that will be green for 40 seconds and then turns amber or red for a total of 60 seconds. So the question here is, what is the probability of the light to be green when Heiji reaches the intersection at least once a week? Okay, firstly, we need to know that each trial is independent with P equal to 0.4 and Q equal to 1 minus P equal to 0.6. Secondly, we also need to know that there are 5 work days in a week. To get one green light on those 5 days, her waiting time will be between 0 and 4. So, to calculate the probability of X between 0 and 4, you will be calculate P plus P with 1 fail plus P with 2 fail plus P with 3 fail and P with 4 fail. So, we will get the answer 0.92. The second question is, what is the expected number of days before the light is green when she reaches the intersection? Here, we need to calculate expected number where Q over P equal to 0.6 over 0.4 equal to 1.5. So, that's our answer, 1.5.